Hey y'all, this is part 2 of the multi-period work schedule problem. So I'm just going to jump right back into our constraints. We were on the March constraint. And check out part 1 if you haven't, or you might be a little confused on what's going on in this problem. So we're looking over here at this row, and we see that, and I just wanted to note also that the reason I can't do a for all loop, you might think, oh, well, we're increasing to a new time period, so why can't we use a for all loop? And that is because I have not yet figured out if there's a way to index and add 1, but I've tried doing that. I've tried doing something like I plus 1, but that definitely does not work. So, and that's what we would need to do for the right hand side, since it's a month greater, or maybe we could do something like I minus 1 for this side instead, but that unfortunately does not work. So comment below if you know a way to fix this, but for now I'm just going to type out each constraint, which isn't too bad. Just a little time consuming. Just realized I deleted that. And then our April constraint is going to be the same, except this time the left hand side we have 3 as our index number. And then on the right hand side we got 4. Finally, our last constraint for this problem is going to be our May constraint. That on the left hand side, same equation, we're just indexing with 4. And then 5 on the right hand side. Alright, so that's the constraints, and I'm just going to use the really basic problem code that I always use. I'm going to copy and paste from this problem. So of course we need our prob.solve function, parentheses, and then I'm going to use this this loop. I'm going to say for v and prob variables, and I just want to print the name and the value. So basically it's going to tell us how many trainees we have during each month and how many skilled people we have at the beginning of each month. And then the minimum total cost will print as well. So let's go ahead and run this. Prob not defined. Looks like put a 0. So here's our solution, and you can look over here, and if we want, let's just see what happens when we change these to binary. I'm not really sure, but I want to see, maybe it will give us the same but in integers. If not, either way we have the right solution. No, that is not what I wanted to do. I meant to say integer. Integer. Okay. And I guess it doesn't really matter. It's not making a difference. Anyways, just ignore that. So we run it and we get the right solution. So our total minimum cost is 593,777, and if you round this, that is what we got in Python. X1, which is right here, we just use different names. X1 is 0, X2 8.45, x3 11.45, x4 9.52, and then x5 is 0, and 50, 47.5, 53.58, just showing you guys that these are correct, 62.35 or 34, and then 68.75. So if you round these, you get the correct answer, and hopefully now you know how to solve a multi-period problem or solve one that's similar to this. And check out my next video for more Python problems. Bye!